Alright, so impulse number one, a golf club hits a stationary 0.05 kg golf ball with an average force of 5 times 10 to the 3 newtons, 10 to the 3, 103, 10 to the 3, accelerating the ball to a speed of 44 meters per second. What is the magnitude of the impulse imparted to the ball by the golf club? So they want to know what your impulse is, right? They want to know what J is. And then, hold on. This is it's final velocity. I forgot to mention that. And your initial velocity is 0 because it's a stationary golf ball. So what's your impulse? Well, you know your impulse is equal to a change in momentum. So J is equal to change in momentum. And if this isn't clear for you, let me make it more clear. Change in delta P, change in momentum, change in MV. All right. Well, since your mass never changes, well, it can also be written like this. Because your mass never changes, only your velocity changes. So let's solve for this formula right here. We're given this formula. So uh, impulse is m delta v. Well, what's your mass? 0.05. Change in velocity, vf minus vi. 5. Final velocity, 44 minus 0. 0.05, 44. But by 20 is 2.2, I guess, somewhere around there. Yes, and that is an answer. That is an answer. 2.2 Newton seconds. Newton seconds. So the choice is A. So number 2, mass of the kilogram car is 1,000 kg, traveling at 20 meters per second. Impulse, 2,000 Newton seconds. West, very important. What is the final velocity of the car after the impulse has been applied? So the initial velocity is 20, so I want you to know what your final velocity is. Well, again, we know that J is equal to delta P, because that's the definition. Impulse is change in momentum. And since we know that our mass never changes, we can just write it like this. M delta V is equal to M VF minus VI. That must mean that mass, well, we know what our impulse is, so we don't need to write like that. Impulse is 2,000, M is 1,000, VF is something, VI is negative 20, divided by 1,000, is equal to 2, VF minus 20, plus 20, plus 20. Let's go all the way over here because I have no more room. So 2 plus 20 is 22. And I got VF. That's 22 meters per second. That should be my answer. Is that a choice? Yes, it is. D. D. If I were the Regents test makers, I would have made two choices. 22 meters per second east. And we put that as choice A, and then 22 meters per second west as choice D, and that would be the correct answer. Choice D would be the correct answer. Because then it tests students' ability to read. Alright. An airbag is used to safely decrease the momentum of a driver in a car accident. The airbag reduces the magnitude of force acting on a driver by increasing the length of time the force acts on that driver. Because we know, again, I demonstrated this in class. I can either apply great force and get something moving in a very short amount of time, Or I can push it, I can push the chair slower over a longer duration of time. So how do I demonstrate this? How does it all make sense? Well, we know impulse is also equal to F net times T. And if I apply, let's say, a force of 500 newtons, let's say, and over, uh, just 1 second, sure. 1 second, my impulse is still 500 newton seconds. Well, let's say I want to apply a different force, let's say over a longer duration of time. Let's say I'm applying a net force of 100, and I'm applying it over 5 seconds. Well, if you calculate all this, you're still going to get 500 newton seconds. Alright, so that's how that makes sense. That's how an airbag works. Increases the time that it takes for you to get to zero. Mass is 3 kg. A 3 kg object is acted upon by an impulse having a magnitude of 15 newton seconds, so your impulse is 15 ns. What is the magnitude of the object's change in momentum due to this impulse? Well, you know by definition, impulse is change in momentum. They're giving you the momentum. And they want to know what your change in velocity is. They want to know what delta P is. Well, you just solved it. You just need to read the problem. The answer is B. Uh, 75 kilogram hockey player, speed 6 meters per second. What's the magnitude of average required force? F net is what? B final 0. Time is 0.65 seconds. So you know J is delta P, which is M delta V, and you know in the reference table, J is also equal to this, which means we can do this. Because I'm just equating J. My F net is what? That's what we're going to find out. My T is 0.65. My mass is 75. My delta V is -6. Why is it -6? I'll show you. Because VF is 0 and VI is 6. So you're going to get -6. F net 75 times -6, it gives you -450. And then you divide 0.65 on both sides. Alright, so divided by that, you're gonna get somewhere. Let me just look at the answer choices. 690. Yep. 690. Most likely answer. Above is 6. Let me just make sure on my calculator. Yeah, 690. Somewhere around there. C. 6 of 0.49 kg baseball, initially moving at 15 meters per second, was brought to rest in 0.040 seconds. And they want to know what F net is. So they want to use the same exact formula. M delta V. And if you're unsure about how I got to this point, watch the previous examples. F net 0.04. And I don't really have enough time. I mean, not enough time, not enough space. Let's just T 0.04. I'm pretty tired at this point. I think I've made 3 videos straight. This is my third video, and I can't be as enthusiastic anymore. It's actually very difficult. Fairly difficult. Fairly difficult. This is gonna be a number. It's gonna be a number. Let's see which answer choices best fit. I think C. I think choice C is the answer. Just from looking at this, it's either choice C or choice D. It's choice D. Yeah, it's choice D. Yep, choice D. So the answer is somewhere around 56 newtons. And that's your answer. D. 7. The motorcycle is being driven on dirt path, hits a rock. So if you just read this problem and go step by step, sentence by sentence, you should figure out what your nodes are. Magnitude of the average force acting exerted on this cyclist by the haystack is what? And so if you know that he's just probably going to stop, brought to rest. If he's brought to rest, you know your final velocity is 0. And you're just setting up your formula again. If you understand, if not sure how I got this, delta V is VF minus VI. So VF is 0, VI is negative 20. I mean, not negative 20, it's just 20. 60 times negative 20. Negative 2 for 400. So that's your net force. And they want the magnitude. They want the magnitude, so you don't even care about the positive number. And the answer should be 2.4 times 10 to the 3, and that is D. Choice D. Choice D. Alright, that concludes the impulse one.